All right, so let's talk about section 2.7, transitive property and substitution. Okay, so we are going to start with transitive property. This property you guys see a lot all throughout geometry. So I just put this up here really quickly. You got to scroll down for your notes. If I have the same grade as Steve, and Steve has the same grade as Bob, then I have the same grade as Bob, okay? If I have the same grade as Steve, and Steve has the same grade as Bob, then I have the same grade as Bob. That is the transitive property, okay? The transitive property, you guys should have learned about this in, I think, 3rd grade probably. The transitive property holds true also with angles. So we have Theorem 16 right here. If angles are congruent to the same angle, then they are congruent to each other. If segments are congruent to the same segment, then they are congruent to each other. In other words, if me and Bob are both congruent to Steve, then me and Bob are congruent to each other. Okay, so if A equals B, and if B equals C, then angle A will equal angle C. That is the transitive property. That's it, okay? Notice that we're working with 3 angles. Up above, we're working with 3 people, me, Steve, and Bob. Okay, you can also have what's called the double transitive property. Okay, and that's just working with 4 angles or 4 people. If I have the same grade as Steve, and Steve has the same grade as Bob, and Bob has the same grade as Nick, then I have the same grade as Nick. Okay, and all this says is if angles are congruent to congruent angles. So here we go. Okay, that means if angle A and angle D are congruent to congruent angles, which are B and C, okay, those are congruent to each other, then angle A has to equal angle D. Again, that's double transitive property. If angles are congruent to congruent angles, then they are congruent to each other. I know I'm saying congruent a lot. Substitution property, again, you guys know this. You literally, it's like sports. You take the quarterback out, you sub the quarterback in. You're not going to put a kicker in for the quarterback, right? So it's substitution of equal values. So if angle 1 is complementary to angle 2, if I told you guys this, angle 1 is complementary to angle 2, then hypothetically, let's say I told you that angle 2 equals angle 3. These are equal to each other, right? So equal players. That's a quarterback, that's a quarterback. Then we can take angle 2 out and substitute in angle 3. That's substitution. Okay, so you're taking something out and you're substituting it in with equal value. Okay, so I'm going to go over a couple proofs with you guys. Again, we write down our statements and our reasons. Okay, we're going to put our first statement. FG is congruent to KJ. So I'm going to put my tick marks in there. And that is given. Step 2, GH is congruent to KJ. Okay, and again, that's given. So GH is congruent to KJ. So notice KJ already has 1 tick mark. So for GH, I'm also going to put 1 tick mark. Okay, I'm noticing some things here. And again, color is very helpful. So if you want to color the segments, this blue segment is equal to this pink segment. Then you also have the pink segment equal to the orange segment. Okay, so again, oh look, that means that FG has to be congruent to GH. Okay, and my reason would be if 2 segments are congruent to the same segment, then they are congruent to each other. Congruent to each other. Okay, because the blue equals the pink and the orange equals the pink, then the blue has to equal the orange. Okay, now let's take a look at what we're trying to prove. We're trying to prove that KG bisects FH. So in order for FH to be bisected, it has to be split in two equal pieces. And lucky for us, it is the blue and the orange. So I have enough information, and I can say that KG bisects FH. And how did I know that? Okay, go back to step 3. This is your if part. So if a line cuts a segment into two congruent segments, and it did in step 3, then it bisects the segment. And that is from step 4. Okay, the if is from step 3, the then is from step 4. And you're finished. You proved what you needed to prove. Okay, your last step is always what you're trying to prove. Let's try the next one. So statement, reason. Step 1, angle 1 plus angle 2 equals 90 degrees. Okay, so I'm going to put a little 90 in there, given. Step 2, angle 1 equals angle 3, given. So if angle 1, okay, so we're trying to prove that 3 and 2 equal 90. Well, if angle 1 is equal to angle 3, and that's what I'm trying to prove, then can't I just take out angle 1 and put in angle 3? That's all I'm trying to do here. Okay, so again, if you need the colors, here's the colors. So I'm trying to prove that angle 3 is angle 3 plus angle 2 is equal to 90, and that is just the substitution property. Okay, angle 1, look at step 1. Angle 1 and angle 2 equal 90. 1 and 3 are equal players. Okay, so they're both quarterbacks. They're both wide receivers, whatever you want to think of them as. So if 1 equals 3, then I can actually take the 1 out and substitute in the 3. That is the substitution property. Okay, so that's the difference between transitive and substitution property. Substitution, you're just taking something out and replacing it with equal value. Okay, this is 2.7.